the second lecture of multi-threading. And in last session, we simply talked about what thread is, what multi-threading is, what are the different way of creating thread, and I had shown you some example of it. In this session, we are going to talk about use of join method, right? One thread can join other thread. I'm going to talk about that. It's okay. Join, right? What is the use of join? So guys, let's understand this program. This program is there already. I just need to tell you. It's okay. It doesn't matter. So here you see, Ram, this is one of the tasks. I go ahead, right? Hmm. Simple. Yesterday you have seen it, right? But tell me, who is going to call the run method? Thread. Already we talked about. Yes, you know.
Right.
Every method in
Yes.
Java is called by thread. Already we talked about. Yes, you know. Yep.
Yeah.
Please, if you want to print the name of the call, hey, who is calling to me? Who is calling to me, right? You want to print the name of the thread. What you need to do? First of all, you will use this. It will return you the thread object. Ram. It will return
Mm-hmm.
thread,
Current.
current
Right.
thread. And if you want to print the name of it, you can call get method, get name method on this method. So tell me, this much will give you the name of the thread which is going to call this method. Say yes.
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 Now you want to know this run method is always called by the thread, but thread is an object. If you want to print the reference of the object, right? What you need to do, Ram? You have to call here system out
She's
sys
out.
out. In IntelliJ it is sys out. You can call that this method. Hey, Ram, you need to understand.
This dot.
This means you are basically holding
Current
the
thread.
no yeah object, right? Hello.
Mm-hmm.
This will basically give you the address, the reference of the object who is calling the run method. But this will give you the reference of the thread. Are you following me? So sometime this and this could be same, but sometime different. There would be difference also. That will be different as well. Clear? This means man, it will be always called by some object, right? That's correct. But it will be also called by the thread, right?
Mm-hmm.
In this case, so who is going to call it? Your thread. Okay, I'll tell you, right? Ram. So this is basically giving you the address of the calling object, and this will give you the reference of calling thread. Ram. So you have to understand difference between both, right? This
Mm-hmm.
gives you calling object reference, right? Calling object
Object
reference. You know it.
reference.
It's not new thing. This, so I'll give you the reference of calling thread. Nice. Hmm? Yeah. Anybody have any confusion? No. This is going to print how many times?
Object.
1,000 times. It's saying keep crying. Okay. And I stop please. It's saying, thread say stop crying this time. So Ram, go ahead, right? And stop please, whatever. Both are just example of thread or task. Only task, right? I would say these are
Mm-hmm.
runnable tasks. Why? Because this task is created by the runnable interface. I'll show you maybe next session. There is another way to create a task, Ram, using using callable. Oh, in multi-threading, how many ways we have to create a task? Two ways:
Two ways.
implementing runnable and implementing callable.
Extend.
Callable. No. I'm not talking about how many ways we can create a thread. Remember it.
Mm-hmm.
Creating thread, we have two approach: extending thread class and implementing runnable, right? But I'm talking about what are the different way to create a task. Task. Answer is two approach: implementing runnable and implementing callable. I make you confused?
No.
Callable and runnable. We have two approach of creating
Task.
task. In this, I'll show you callable is better because it was introduced in Java 5 later. We'll talk on that. Okay. What is the difference between runnable and callable? It is one of the most frequently asked interview question. Difference between runnable and
Naren
callable.
sir, is a callable is a also interface?
Yeah, yeah. Callable is also functional interface. Functional. I can show you. You know already what is a functional interface, right? An interface which contains only one abstract method. That's it. And functional interface, you can annotate with which notation? At the rate functional interface.
Functional interface.
Clear?
And again, we have also something with the name of predictable and also comparable in function interface, right?
Yeah.
Comparable.
Supplier.
Yeah, comparable and comparator both are functional interface. That's correct.
And predictable, something like that, I think. Something like that.
Predicate.
That's
Predicate.
Predicate, sorry,
predicate.
you're right, predicate, yeah.
Yeah,
And
that is also
supplier too.
supplier too. He's right. Okay. 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 Like here, what I'm doing, Ram, it is simple. Same approach, man. I'm creating an object of I go ahead and I stop, please, right? Then you are creating thread and starting. You know it, right? Yep.
We
So
have it.
like here, both threads started to run, but here main thread is also running, right? But my intention is, Ram, my intention is this line should be execute in last, right? But right now, if you run it, it is not going to execute in last. Why? Because main thread and other threads are running parallel. Ram, am I right or not? Why this statement is
Mm-hmm.
not coming in the last? Because main is running parallel, man. So main may be able to finish this much execution, right? Other may be executing.
Mm-hmm.
The, but what was my intention? My intention was this message should come in the last. Ram. So what you need to
There's
do?
a
Okay.
there's a way to synchronize this also, right? Which thread comes
We'll
first.
talk on that. We'll talk on that, right? So the here what you need to do in this we have parent and child relationship. I don't know you understand or not. Let me make a diagram for it. What I said, we have
Parent and child.
parent and child. So you need to understand which one is the parent and which one is the child. You know parent, right?
Parent
Like
is
here,
man.
main is parent here because main thread, right? Every thread has a name, ID. You know it, right? So you see,
Mm-hmm. ID name status.
this is the main thread. Inside main
Mm-hmm.
thread, you are creating two child thread. Can you see this? Yeah. So you know it, right? Which one is main and which one is child thread? Which one is the parent and which one is child? Makes sense, or you got confused? This main thread is creating two children.
Thread
Oh,
1 and thread 2, right?
yeah. So main, oh, main thread. Who creates main thread? It is created by programmer or it is implicitly managed by the Java virtual machine. I want this answer from
Program
main thread I'm talking about.
Main is JVM.
JVM.
man is
Java Virtual
JVM.
Machine.
Virtual machine. So you know main thread is created by JVM and JVM and that main thread calls main method. You know it. But this thread,
Mm-hmm.
right? I haven't given any name of my choice. Can you give the name to it? Yeah, you can give a name to it, right? I'm not giving any name to it, but it will take by default thread 1 and thread 2, right? But if you want, you can give the name to it, right? I'll show you. So this is the diagram for it. Parent and child. And I told you, child thread can access the address means memory. A child thread can access what, man?
And access memory.
Memory of mem-
Parent.
yeah, memory of parent. Please remember it. I'll show you. Okay. So no confusion. Like here, my intention is I want this statement should come in the last. So what you need to do? Calling thread. Hey, who's calling this thread 1, thread 2? Main thread. So main thread has to join children. So what is the benefit of it? If main thread joins child thread, then main thread will be block over here. Hey, like here, all the three threads are running, right? But here main will be blocked. Main will only go ahead after this when both will finish their execution. Ram, do you understand the benefit? Why I'm joining? Because I'm saying, hey main, you are not supposed to go beyond it. Once thread 1 and thread 2 are finished, then you can go ahead. You got it or you got confused?
So join is used for block.
Yeah, calling thread. Who's going to be block
Calling
over
thread.
here? Calling. Who's calling join? Hey, which thread is calling, making this call? Main thread.
Main thread.
Main thread.
And which object is making this call? Thread 1, thread 2, right?
Thread 1.
So that's why I'm telling you. When you call a method, it is always called by a thread, but eventually it is called by object. That's correct, man, right? So my question is, this block of code is executed by which thread? Let me write it. This code is executed by which thread? Answer me.
Main thread.
Main thread, right? And who's going to call? Who's going to call join and join? Thread
Thread
1
1
and
and
thread
thread
2.
Thread 1
Yeah.
and thread 2.
So in this way, the main thread is going to join thread 1 and thread 2. Both, if both finish the execution, then this line will come. I hope you understand the use of join.
Join can block the
Yeah. So let me
callable
tell
method.
you, I'm going to explain you the concept of daemon and non-daemon. Okay. Okay. Let me see if I have some diagram in slide. Otherwise, I can make it. Daemon and non-daemon. By default, main thread is daemon and non-daemon.
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 Non-daemon. So you need to understand the meaning of daemon and non-daemon. Let's start. So this daemon and non-daemon concept is related with parent and child relationship. By default, main is non-daemon. If main is non-daemon, its children will be also
Non-daemon.
non-daemon by default. So let me see if we have some example of it. Oh, nice. We have.
Right here, I have a question, sir.
Please go ahead.
Parent thread can access a child memory?
No, it's not
No,
possible.
right? Okay.
Daemon. Let's do that. No need to take much tension as long as I'm here. Okay.
In the class, no tension. In
Yeah,
the
yeah.
work,
Class, I can copy it. We need two class, car and bike. Okay, not a big deal. Please, it is nothing, right? Like here we have bike. Can you see this? Bike implemented, and here I have a constructor. Basically, I'm just giving a name to the task, right? Ram class implement runnable.
then runnable thread
So this is clear,
interface.
and this is main thing, right? This task is going to be execute this much time, right? This is the
Line number
case.
10 is a constructor.
Yeah, it is a constructor. Why we have constructor in case? I want to basically give the name to the task. This is clear or you got
Okay.
confused? So when you make a task,
No,
you
this
have to
is
pass
clear.
the name to it, and that name I'm printing over here. Same thing I may be doing for car also. You see, car implement. Anybody have any question query? Car class, and this is a task. Can I say this is runnable task?
Yeah.
This
Yes.
is runnable task.
Also called as runnable interface in the thread.
This is runnable task. That's it. I hope this is clear. This in and here in daemon example, right? So by default, all the threads are non-daemon because main is non-daemon. The here what I'm doing, I'm making thread for car and bike. This thread will execute this car task, and this thread too will execute bike task. So before starting it, there is an attribute in the thread. I'm just saying it is daemon true. Daemon true means now it is daemon. Hello, what I said? Daemon true means it is daemon. After making daemon, you can start it because once thread is started, you can't change its nature. But your question may be, what is the meaning of making it daemon, right? So let me tell you,
Yes.
meaning of daemon
What
and
is the
non.
meaning of
Yeah,
daemon
yeah.
first?
Like here, we have three threads. All are running parallel. Say yes. So
Yes.
Assume all are running parallel. It takes 20 seconds to finish, right? And this takes 30 seconds to finish, Vishal. And this takes 28 finish. It's execution. So first of all, assume first use case. Ram, first use case is main will be always non-daemon. Say yes. You can't change
Yes.
nature. Why? Because this thread is not in your hand.
By
So
default.
by default, non-daemon. I talked about already, right? And these are first you can say non-daemon. First use case, right? So what happened? Like here, if all three will execute, right? Who will finish their execution first? Parent, right?
Man,
So
man,
if parent finish their execution, parent cannot terminate. Why? Because still its children are executing, right? So if parent is non-demon already, we talked about. If children are non-demon, what happened? Once parent finishes execution, he has to wait for their children. Are you following me? So see, all will run parallel, right? So this program total will take how much time? 30 seconds at max. Say yes, because all are running parallel.
Yes.
hmm
Vishal. So if children are non-demon, what happen? Parent finish the execution, but parent will not terminate. Parent has to wait for next 10 seconds. You got a point? Why parent is waiting? Parent is
because to
my
finish the
To
thread
children,
one
execute the
child,
child
child.
child
child
thread.
thread and child thread, are taking more than parent, but parent will not terminate. Why? Because the his children
Children
is
child thread is still running.
non-demon because of non-demon in nature. I hope you understand. Yeah. So in this case, main has to wait how many seconds? 10 seconds, right?
Third, 10 second.
Let me give you another use case. In this use case, both children are demon thread, right? So what happened? If children are demon, main will not wait for their execution. Once main finishes its execution, children has to be stopped immediately. So what happened in second use case? Main is saying, hey, I finished now in 20 seconds. Other thread, stop, right? So main, if children are demon thread, main will immediately terminate. It will not wait for them. They have to be stopped. Got a point? So in this
Right.
situation, thread 2 will only execute for how many seconds? 20 seconds.
20
And
seconds.
thread 1 will also execute for 20 seconds. Got it? Your
Got
question
it.
may be why this kind of scenario is, right? See, actually this kind of daemon thread we make because it sometimes it is supporting task. Supporting task means as long as main thread is there, it makes sense for them. If main thread is not there, it does not make sense for them, right?
Mm-hmm.
Let me give you one layman example. You think, hello, if you believe in God, right? Like, hello, you believe in
Yeah.
God,
Yes.
and you can think world, right? This world, whole world, this whole world is actually parent thread, and we are child thread, right? So you think about a relationship between world and ourselves. It would be what relationship? Suppose world is non-demon thread. So we are a demon thread. Yes, because
Yes.
the whole world is going to destroy. You would not say, hey, let me eat samosa, right? No, it doesn't make sense, right? Because if main thread is going to be destroyed, whole world is going to be destroyed, right? You have to be destroy immediately. You have to die immediately. Yes, simple. So
Yes.
in that
So
sense,
right here, main thread is a god, right?
yeah, main thread is God, non-demon, and we are always demon because we are mercy of world. As long as world is there, we are there, right? Make sense?
hmm
So
Makes sense.
I will show you in JBM there are a lot of supporting thread like thread scheduler, garbage collector. You know what I'm saying? Thread scheduler, garbage collector. These are the example of demon, non-demon. Think about it. Again, I'm talking about. If I'm talking about garbage collector, you think about it. Garbage collector is the supporting thread. It is helping JVM to allocate and deallocate the memory. So garbage collector should be daemon thread or non-daemon thread. Think about it.
Non-demon thread, I think.
No, daemon man, because garbage collector is only there as long as JBM is there. When JBM is going to be stopped, this supporting
They
thread
don't
has
need
to
to
be.
collect anymore.
And again,
Pardon?
what is garbage collector?
Garbage collector is a thread which is responsible for allocating and deallocating the memory in your program.
Unnecessary code object creating it
Yeah,
collects, right?
GC
And
is
then
a
it block to run it.
GC is a daemon thread,
Demons.
which what it does, man, which
Allocates
allocates
Right?
and free the
unnecessary
memory.
memory.
Yeah, GC is a daemon thread which allocates, right, and free the memory. I hope I'm making myself clear.
Yes.
So GC is a daemon thread. Why? It is up to mercy of the JVM. As long as JVM is running, right, your Java virtual machine is there running, this thread is there. Once JVM stop, this thread has to be stopped immediately. I hope you understand the reason why supporting threads are
Mm-hmm.
daemon.
Damn.
So you can make this decision. Your thread is supporting thread or what, right? Sometime your design should be once main thread cannot terminate unless and until or the children finish their execution. Then you can make your children as a non-daemon, right? If these children are supporting thread, right, it is on mercy of the parent, then you can make it daemon. I hope you understand. So can you see this, man? Eh. So you tell me, in this situation, car and bike both will execute completely? No, because both are daemon thread, right? Once main finish their execution, they have to be stopped. Vishal, you tell me, in this
So
case, car task and bike task will execute completely? They will execute starting from 3 to 3332. No, you cannot give the guarantee. Why, man? Because they are at mercy of what? They are only
not
Mercy
demon.
of Satan.
mercy on main thread. Can I run
Yeah.
it? And here,
Wait a minute.
the here is alive means that thread is running. T1 and why am I writing it? This is not mistake. Oh man, I make you confused, or you got it. Let's make it. Let's make it.
Can you explain me line number 18 and 19, right? We call the object of thread to set daemon. So,
Oh man,
huh?
by default, all the threads are non-demon. I'm just making it demon before starting it.
Okay.
That's it. If you don't make it by default, it is non-demon. So in this case, since child threads are demon, their execution will be not finished completely. You can see it. You see, car is only running up to 49. BMW Apache bike is running only up to 14. Got confused? Why
No,
children? While childrens are not finished completely because they are
because
Demon. We set
non-demon.
them to
Set
true.
them.
demon.
Demon.
And just comment
Mhm.
it. If you comment it, you will see
The gods
child
of 300.
parent will not terminate, right, unless until both the children finish their execution. That's it. Now you can see. Can you see this? It is a all both are executing up to 332. Ram,
Yes, sir.
you got the idea? Demon, non-demon. So
Yes, sir.
demon and non-demon concept comes in case of parent and child. So parent and child relationship always will come in the picture, man. Right?
Yeah.
So there is a
Mhm.
parent thread for all the thread that is called main thread, which is created by JVM, and that thread is daemon and non-daemon. Non-daemon. Can you make it daemon? Can you make our main
Yes.
thread daemon? No. You cannot change the
No,
nature of the thread.
no.
Once it is started, you can't change the nature of it. Can you change the ID of the thread? No. Can we change the name of the thread? Yes. Name you can change, right? But you cannot change its
Yes.
nature. This is clear to everybody?
At what
Yes.
case we can use it, sir?
And everywhere, right? Normally, whatever thread you make, it depends on your logic, right? You cannot stop
Mhm.
your main program unless and until children finish, right? Otherwise, there will be partial completion, right? In that case, your child will be non-demon. But if it is supporting, you understand? I am main actor and you are supporting me, right? Then in that case, you will be demon. Because your presence is not important, man. My presence is important. As long as I'm making sure you are doing in the background, right?
Mm.
Are you following me?
So to completely finish the education, so we need have to whatever diamond like a main class as non-diamond, right? So child class also need to be have like a non-diamond, right? To completely
Non-demon, demon.
education.
Yeah, yeah, it depends on. You are right. If you want,
Mhm.
your child should always execute completely. Make your child as a non-demon.
Okay,
That's
that's
simple.
like that.
A next concept which is very very important, synchronized. You may be you may be hearing this word here and there, right? Synchronization, synchronized. Please, I will.
Synchronize and
Again,
tokenization are the same.
No.
main thread
Tokenization
is
is different thing.
always non-demon, right? Always,
Non-demon. Main thread is always non-demon. Can you make
always.
it demon? No, because it is not in your hand.
No.
You are not creating it, man. It is created by the Java Virtual Machine. Synchronized keyword. This is very very important. I'm telling you. Hmm? You may be. I don't know. Have you heard this word or not?
Yes,
Synchronized. Let's talk on
multiple
that.
time.
Synchronize is one of the keyword, right? And let's
Hmm.
understand the beauty of it. Today I'm going to teach you all this synchronized. I need your help. Yes, help me. The
So
here,
how can I help you?
yeah, you can help me. Class, try to understand my requirement, right?
Okay.
Basically, problem, synchronization issue comes in the picture when multiple thread are going to share the same resource. I can give you the example. This synchronization we use in our daily life. You might go to the mall. When you go to the mall, right? Mall, you may be purchasing the cloth. There is a trial room. Remember trial room? And that trial room is shared or not? Answer my question.
Trial norm trial room is not here.
Not shared. What about bathroom? That is also not
Also
shared,
not here.
right? Of course, you cannot
Hmm.
share it, right? So, in order to ensure only one people go inside, what you do, you use the concept of lock. Yes or no? There's a lock in bathroom, or there may be lock, in your towel room. Yes or no? First of all, you have to when you go, we'll check lock is available or not, right? If lock is
Hmm.
available, then you go inside and lock it. Am I right? Other people
Right.
cannot go inside as long as you are there. Similar concept we have over here. Answer to me, guys. I can copy paste code, but I'm going to knowingly show you. Allow me. So basically, what example I'm going to show you? Synchronized, right? Synchronization. Synchronization means you should perform your execution in such a way so that there should be no issue. Understood? Synchronized.
Mhm.
Guys, I'm just making a common code, right? Problem comes with the common code when it is shared. So util, you can write a method, right? Util, yeah, welcome util, right? Welcome util. Please, in this, I'm going to make a static method. I can make non-static method also, right? So what do you want to make?
Public.
Public, void. You can give any name to it, doesn't matter, right?
G.
So you want to make it static or non-static? It is up to you. Let's make it, it's not static. Okay. Integer x. Please, if this program is not clear to you, let me know. I'm knowingly writing it. System.out. This is, you can pass your name as well, right?
String name
This is right. This is your name.
plus
Hello.
message.
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 If you got confused, let me know. After that, I'm going to integer x 1 x less than
X is less than
30.
100
Yeah, you can write anything. Doesn't matter.
plus
So
plus.
performing
So
some
X.
task. Performing some task. Please help me. And here you can print the value of x plus x. And here you can print the name also. Please name. Performing some task. Hmm? It's okay. You got confused. No. Done. Vishal, this is the
Yes.
code, right? And you can write execution is finished by name. Anybody have any confusion regarding this method? No. Vishal? No confusion. Am I right?
No
Yeah.
confusion. No.
Oh, this is simple method, right? And it can be called by anybody, but you have to pass two parameter, name and message. That's it. So I'm going to show you the use of synchronized keyword. Synchronized demo. Hello. I can make a two thread, right? Using Runnable. So guys, you have to allow me. Like here,
Yes, sir.
I can make a thread using Lambda also. Can you allow to me? Yes. First of all, how can make the thread on the fly? Ram, you say me
Thread
thread.
T1,
Thread T1. I don't know. You understand this much or not? You can make the
new thread
thread, and here I don't- are you following me? Like here you can write the
for
something like
I.
that. If you don't understand, I can make it simple for you, right? This is the lambda expression for runnable. I don't know. You can understand this or not. Otherwise, I can make what? I'm going to make a task man class thread E implements
Implements runnable.
runnable. Instead of thread, I would say task tasker. You can give any name to it. Doesn't matter. Runnable. Please, you can help me, right? So here, what happening? This task, right? This task is going to call which method? Welcome util, common method, and it can pass its name and message is hello. Oh, wow, this is really cool. Vishal,
Mm-hmm.
when you run this task, what it will do? It will call this G method, right? Yeah. At the same time, right? I'm just going to make another method finisher, another task. I'm sorry, and you are passing it. Wow, this is really awesome.
Cool.
Cool. Already you did. You have to make a difference, right?
This
Wow.
is really magic.
Yeah. So guys, how many tasks we have? Two tasks. Tasker and finisher. Which one is going to execute first? Don't know, right?
We
So
don't
if you
know.
want to run this task parallel, what you need to do? Here you have to make a two thread. Allow me. Can I make like this? Ram, in shortcut, thread,
New
and
thread.
here you can pass object of task.
Task.
And you can start it at the same time. Vishal, this syntax you understand?
Yes.
I am creating thread and passing the instance of the task and starting it. Both the tasks are started, right? Both the thread starting executing the both the tasks parallel. Yes, here
Mm-hmm.
we have the thread one. This thread one is executing which task? Executing tasker task.
Task or task.
And thread two is
Finish your task.
executing finisher task. You know it. You say I know. Go ahead. Nice. And both are going to call the same method at the same time. Yes,
Thread 2, right? In
So,
the
so
comment. Thread 2, line number
yeah,
24.
yeah, that's correct. So you tell me, both thread are going to call run method. Tasker will call its own run method and finisher will call its own run method. But eventually they are going to call the common method. Who will go inside the G first? Answer to me. Don't know, right? Anyone can go. Yes,
Yeah.
Hmm.
Vishal. Which will go inside
Anyone.
this G method? Answer is I don't know. Anyone can go. But you tell me, if suppose first thread goes inside, right? So Other thread also can go inside, right? Even though first one is doing their execution, that is bad or not? Let me run it. If you see the output of the program, Vishal, what is the weird thing is? See, the weird thing is this is finisher. Hello, wow, this is really awesome, right? Its meaning
Mhm.
is, you see, in both the both thread are going inside the same method at the same time. I don't know you got my point or not. My intention was in G method, only one thread should go inside. As long as that thread is inside, other is not supposed to go. Vishal. But what happening right now? What I said? I said as long as one thread is executing G method, other should not go inside. But this is happening? No. Vishal. What's problem right now is suppose first thread is executing, right? This G method. Then second thread also goes inside it. That is the problem. Do you understand the issue? Sir, you are not replying. Vishal, who is going inside the method? Any thread can go, right?
Both.
And
Yes.
suppose first one is still executing, but second, can you see this? Performing some task, name tasker, finisher, right? Both are calling the same method, same time. Yes, you know? That's
Yes.
problem is. But what was my intention? My intention is if first thread is calling G method, other thread should not call it. Do you understand? Or I can make a diagram for you.
Make a diagram.
Vishal. Okay. Like here, you assume we have two thread. Basically, I want to show you the problem. Thread 1 and thread 2. And both the threads are calling their own task. Remember? If you say this is thread 1,
Tasker.
this is thread, right? They will call the task. Which task?
Tasker and finisher.
Yeah, you know it, right? Yeah. Let me show you. Please, you have to just say no if you don't understand. I'm not in hurry. Tasker and next one is finisher. So tell me, when you start your thread, both tasks will come in the picture, right? Both are going to call run method. But in this, we have common method Z. So what is the issue with this, Vishal? Issue is like you start your thread, right? Start and start. So both will go inside the run method. Yes, you know. So
Yes.
first thread, while first thread goes in G method, other thread will also go inside G method or not? Yes,
Yes.
it can go. It is not in your control. You got a point now?
Mm-hmm.
Vishal, both are going inside the same method at the same time. Say yes. So,
Yes.
so my intention was if first thread goes inside, other thread should not go inside. He should wait outside the method. That was my plan. But as per the current code, it is not happening. You got the problem?
Mm-hmm.
In this method, when first thread goes, second thread also goes inside it. That's why output is mingle. Hmm? Got confused or you got the idea? You got the issue, Vishal. In
Got
this,
it.
you don't have any
Got the
control,
issue.
right? You see the problem? That's why output is mingle, which you don't want, right? My intention was at a time only one thread go inside it, not other. So you can use here one keyword that is called synchronized. So what is the benefit of it? If you use synchronized keyword, Vishal, the moment when you put the synchronized method, this method will ensure only one thread will go inside the method at the time. That's it. Which thread? Nobody knows, right? It could be first, second, anything, right? Tasker, it may be finisher, Vishal. But by putting
Mm-hmm.
this method, what is the benefit? By putting this keyword before the method, what is the benefit? Only one thread will go inside G method. Can I show the output? Now
Yes.
output won't be mingle. Let me run it because of synchronized. Can you see this? First of all, you see tasker is inside, then tasker is executing completely. Then finish, then finisher goes inside it. Vishal, I don't know. You got my idea?
Yeah, got it.
What
Synchronized,
is the
right?
ben? Yeah. What
Serialized.
is the serialized? No, no. Serialized is different thing. Synchronized is different thing. So do you understand the benefit of putting synchronized before the method? Yeah.
Mm-hmm.
What is the benefit of it?
So
People,
both
you are
of them doesn't go inside one method at the same time.
exactly, exactly. Sure, you are right. What about other people? Noor,
Got
you
it.
got confused?
I'm a little bit confused. Yes, could you
What's
repeat that?
confusion?
Like how it goes inside that the one Vishal responded.
Man, if you see in the photo
Mhm.
here, actually T1 and T2 both thread are starting at the same time. They will go
Okay.
inside their own task run method.
Okay.
And thread 1 has its own run method and thread 2 has its own run method. And both are calling the Z method. So both will go inside the same method at the same time.
Okay.
Output is mingle. First thread is
Oh,
saying
okay.
this is my
That makes
name,
sense.
hello. Then second came, hey, this is my name and hello. Oh my god. Mingle, right? Overlap.
Yes.
So how you can avoid it so that only one thread can execute it at a time? Only one thread should execute this at a time. What you can do? You can use
Synchronized
synchronize.
keyword.
That's it.
Okay. That makes sense.
Hello. So it depends on the scenario, right? Oh, oh man, it depends on the scenario. I can show you the some program, right? And you can fix it using this keyword. Make sense? Okay.
Yes.
Like here, I'm telling you actually how this is happening. If you use synchronize keyword, right? There's a concept of lock. So then how it is possible one thread can go inside it? So when a first thread comes, Noor, because of when first thread comes, thread one comes.
Hmm.
What it does, it checks the lock of this message. Synchronize. Oh my God, lock is there. So it first of all check lock is available or not, right? If lock is available,
Hmm.
then it goes inside it. As long as the first thread is inside this method, lock is not available. Once this thread comes outside the method, lock is released. Oh man, when
Okay.
this thread goes inside the method, lock is taken care by the calling thread. And once this method execution is finished, lock is released. So other thread can take lock and execute it. Oh my God, lock concept is there. Clear? Then here, I have a question, right? I'm just writing another method, and that is also synchronized. Pa, Vishal. This method is not taking any parameter. It is taking just nothing. Vishal, I'm talking with you, right? See, both the methods are synchronized. Okay. Hello, and hello. My dear, see, every uh, when you have a static method, right? So this is a property of class. So you tell me there is only one class level log. Please remember it. There is only one class label log. Ram. So tell me, if one thread is calling this method, other thread can call pa method. You have to answer to me. No. Why? Noor. In this scenario, we have two synchronized method. And in order to call synchronized method, you need class label, you need lock, right? Say yes.
Yes.
Suppose one thread is calling this method, right? Like
Hmm.
T1 is calling this method. So my question is at the same time, T2 can call this method. You have to answer to me yes or no. Answer is no. Why? When T1 comes, T1 says, hey, synchronize is there. I need a class label lock. Then T1 take class label lock and goes inside, then executing it, right? At the same time, T2 comes and wants to call the PAR method. But in order to call the PAR method, T2 needs class label lock, which is already held by other thread. Got it? So as long as, because of synchronized keyword, as long as one thread is inside any one of the method, other thread will not go inside other method. Please remember it. Vishal,
Okay.
you got the concept of it? Synchronized?
Yes, sir.
And you let me know another use case. Public, you have static, right? And simple void. Aha. So my question is, in this scenario, in this, how many method we have?
True.
What about this? Three methods we have total. Ram, suppose we have assume first thread is executing inside this method Z, right?
Mm-hmm.
Third thread can call this method or not of this class. Yes, it can call because it is not synchronized, man. In order to call the
Okay.
normal method, you don't need lock. Hmm? So you are not replying. T3 can call
Yes. For
this
normal
So there
method.
method
is
is we
no
do not need
synchronized.
logger.
Exactly, exactly. You got it? So this concept is only for synchronized method. Clear? So synchronized method, you cannot make it blindly. You should have genuine reason behind it because it will, you know, it will degrade the performance of your application. Synchronize is overhead. You should have this only when you need it. You got this much and you got totally confused.
I got a little confused here. So
You guys are problem is ask why not asking questions? Ask questions where you confused.
I start lost from synchronized, right? So here has a two method and then
Yeah, here we have two methods, right? One
mm-hmm.
thread is calling this method, other thread I said it cannot call pi at the same time. Why? Because we
There
have
is.
only one lock.
Mhm.
Are you following me? Man, you think it is a you have a key, right? In order to call this method, you need a key, right?
Yeah.
T1 takes the key of it, key of the class and go inside and executing it. Other thread comes, hey, I want to call pa. Sorry, I cannot call because that key is held by T1. Got it? So I told you, in order to call synchronized method, you need always lock. You can only call this method, synchronized method, when you lock when lock is available. But for normal method, anybody can call anytime. No lock is required. That's
It's
concept,
like
Ram.
it's like we cannot open two locks with one key.
Exactly, exactly. So here we have lock, and this is also lock, but this lock is opened by only one key. Ram. So at a time,
Okay.
you can go inside one method only, either this or this. But in order to call this method, we don't need any key because lock is not there. Why lock is not there, Ram? Because we
The
don't have
door
synchronized
is open.
capabilities. Ram,
It's open.
where were you
Yeah.
confused? Please let me know. I'd like to answer it.
Mm.
Nobody replying.
Yeah,
No, I'm trying to reply.
I
So
got it.
Okay.
I got it too.
Okay. I have to show you one more good example of it. I'm telling you, this kind of questions, everybody cannot answer it. Okay. So here, I'm just writing a program counter. Please, you have to, here, we have a method void execute. Hello, everybody. What I'm trying to do is, please, you have to help me. Here I have a variable x1. Ram, like here, there would be a lot of methods, right? They are going to increment. So this is going to increment the value of x how many times? You're
One,
not replying.
100? No.
Yeah, they are going to increment this value 5 times plus one. When you call this method, it is going to increment this value by 105. Again, not replying.
105?
Yeah.
1,
So
2, 4,
basically, my
5.
intention is,
105. Yeah.
yeah, if I print the value of public void print, Ram, you have to
Yes,
answer
sir.
my question, okay? And
Mm-hmm.
think about it. See, current value of current
X.
value axis. So tell me, if you call this method 2 times, right, on the
Mm-hmm.
same object, hmm, if you call this method, we can make it Give me a second. You can make it static. Why am I making static? Because I want to make it simple. That's it. Static. Static, right? Everything is static. Please help me. Yeah. So Ram, you tell me if I call this, if this method is called by two thread, right?
Mhm.
So its value should be what, man? Its value should be.
One
You're
of
not
five.
replying. Hmm?
105.
If this method is called two times, you think like this.
Mhm.
So first time when it is being called, its value would be 105. Second time when it is called, its value should be 2010, 210. Yeah, you
Mhm.
guys don't know number mathematics. What is it? First time when this
Yes.
method is called, x value is 0 and it is going to be 5, and then you can say x plus 5, this, right?
Yes,
So
we
this
get
value will become 105, right? Second
Yes.
time when you
yes.
call it, right? Then what
Well, that
happened?
would be incremented with that.
Then it will
20
become
10. 210.
210. Third time, this, right?
15.
Yeah. So basically that is my expectation, right? But you have to ensure at a time only one thread can call it, okay? But let me show you the issue. Hmm? Hello? In this, I'm going to write a main method over here. Ram, I'm just writing code in the same so that,
Mm-hmm.
like here, I'm going to make a thread. Allow me, executor,
Sure.
right? Executor 100. How to make thread, extends thread.
Extend thread or
So
running.
basically, what my intention is, that you can make a thread if you want to give the name to the thread, Vishal. So you can pass the name over here, name of the thread, okay? And this thread name you can set inside the super class constructor. Oh man, what is the benefit of it? You can give the name to the thread. Please help me. I need your help. Huh? Like here, you can pass the name of the thread. You can pass here also, right? What man?
Instrument.
Basically, you want to
So
thread,
name.
thread
Name.
name, thread is called, right? Is calling this method. Is calling this method. Confused? No. Vishal.
Yeah.
This code is going to be called by the thread. The thread who will call this method, he is passing his name as a parameter. That's it. That's why I'm writing who is calling this method, right? Thread. This is calling the method. So here, you need to help me. What you need to do? You can say counter dot execute, and you can pass your name, right?
Get name.
Hello. This method is defined inside which class? Get name is defined inside the super class. Ram.
Super dot get name.
Super dot get name. Whatever name you will set in the constructor, that name you can get over here. Got it or confused? No.
Mm-hmm.
Hello. Oh man, when you create a thread and you run it, it will call the run method, and run method will call this execute
Get
method.
name.
Let me make only one thread, Ram. How?
Yeah.
Help me.
Execute
You are just
100.
making T1, right?
T1 is equal to new.
And here you can give the name of the thread, A thread, okay, or A1. After that, you have to start it. So what happened, Ram? If you start it, this start method will call the run method, and this run method will call execute method, and this execute method is going to increment the value of x by 105. That's it.
105.
And if you want to print the output of it, what you need to do? Kill you counter dot print.
Counter dot print.
What it will print any case? Simple. As long as you have only one thread, there would be no issue. Can I run it?
Mm-hmm.
Guys, do you understand the flow of it? When you are making the object of it, you are just creating the thread and setting the name. And when you start it, this method will call which method? Ram. Even at start, it will
T1 that
call
is start.
the thread run method. And this run method will call the execute method with name.
Okay.
right? And this execute method will increment the value of x by 105. After that, you are printing counter.print, right? Counter.print will print the value of x. Hello.
Mm.
Can I run it? What is the output of it? Any guess? 105. Current value of, okay.
X
Guys,
is
what
equal
happened?
to
No, no, no,
0.
I'm telling you what happened. Here, when you are starting the thread, right? Then this method is also running parallel, right? That's problem is. So what you can do, you can just make some pause of 3 seconds. Ram, just make a pause. Why, man? I'm giving chance to my thread to completely execute it. Are you following me? Who is going to pause here? Tell me.
Flip, flip.
Your
Huh?
main method.
Main method. Who is going to pause here? Very nice. Main method. So Ram, first of all, this thread will execute and finish the execution. After that, I'm printing the value of it. Now I should get what result, man? Correct result.
105.
And it is just waiting. Can you see this? Yep.
Yes.
Hello. But when this problem will come, Ram, if you create another thread and give the different name, so T2, A2 also will call. Tell me.
Mm.
When you start it, again it is going to parallel call the execute method. It will also try to increment the value of it by what?
210.
Yeah, it is going to increment the value, but they will fight because they are going to, increment the value parallel. The problem will come or not?
Yes.
Problem will come. They are trying to increment the value of the x at the same time, right? See, this should not work correctly, but it is working correctly. Ram,
Mhm.
why? Because your computer is running very fast. In order to produce the problem, what I can do, Ram, I can create more
Mhm.
thread. Okay, if you allow to me, guys, how you can create a 10 threads? You can use for
Yes.
loop. Ram,
Yes.
what my plan
Yes.
is creating 10 thread.
Mhm.
Are you following me? So 10 thread is created and you are starting all the 10 thread at the same time. The name is A1, A2, A10 and you are starting it. You got this idea? You got totally confused. I am creating 10 thread and starting it. So what should be the answer over here? Ram, answer should be ideally, tell me, 105 into 10.
10.
Answer should be what, man?
1050.
If you are creating a 10 thread and all the thread you are starting and every thread will call this method. So every thread is supposed to increment the value by 105, right? So if 10 threads are there, its value should be 105 into 10. This value, right? Let's see,
Mhm.
it is there or not. Can you see this? Ram,
Mhm.
this
Yes.
problem is not coming for 10 thread as well. Allow me 100 thread. If it is 100
Because you
thread,
are
its value
using
should be
sleep.
no, 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 not sleep. Your execution is so fast. There is no rest condition. Okay, this rest condition will come for the larger value. Are you following me? So if you have 100, what should be the value of it?
10,500.
Let's see. Now problem should come. Can you see this? No, no, no. It's waiting. Problem is not coming for this value also, right? Let's increment the value.
By
Now I'm
1,000.
getting how many threads? 1,000 thread, right? So ideally,
Mhm.
value should be this much. Mhm.
1,50,000.
Problem will come for sure, man. I know.
Still not.
Still not? No problem. Let me check it. Give me a
10,000.
second. No, 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 no. Problem will come for sure. I'm going to increment the value of it because our computers are very fast. Okay, that's reason. Oh my God, how many thread we are creating? Magic. We are creating 10,000 thread. Let's see.
Get.
Yep.
Yes.
Now problem came. Hello. Why problem is
Yes.
coming? Because you are creating 1,000 thread and all the 1,000 threads are going in the same method and they are trying to increment the value of it, right? Problem
Yes.
came. How you can solve it? You can say this execution should be done by only one thread at a time. So what you can use?
Synchronize.
Problem is solved. Why? Because you are saying if multiple thread will go inside, they will call race condition, right? Value will be mingled altogether. I hope you understand the problem and solution of it.
Yes.
Can you see this, guys? I don't know you
Correct.
understand or not. Vishal and all. This is a very nice example of synchronized keyword. So first of all, I had shown you the problem, then solution of it.
Mm.
So guys, things are not easy. I want you should just go and do this much and come back tomorrow. And tomorrow I'm going to show you the problem, cause of the problem, right? And when you put the synchronize, how it is solved. But you understand or not? Why problem is coming? Because earlier all the 10,000 threads are going inside the same method, right? At the same
Yeah.
time.
Mhm.
See, I'm incrementing the value, right? Somebody came and he has also incremented the value of it at the same time. Problem will come, right? So what you do in order to fix this issue, you have put the synchronized keyword. Benefit of it, only one thread will go inside it. Problem is solved. So today we have just talked about synchronization, right, with the help of examples. And tomorrow we'll talk on the same topic, and I will show you the concept of Java stack. Why Java stack is thread safe, right? And why this problem is coming and how you can fix this problem. All those things we'll talk about in next session. I think, guys, this is
Today.
enough for
Again?
this session, because if I teach you anything else, I don't think you'll understand it. So people, this is enough for the today. In next session we'll discuss next topic. Thank you so much for your time.